No one does. No one. Except
Can you wear your
Demar.
glasses?
What?
Can you wear your glasses?
Let me put on my spectacles. It's like Harry Potter meets Russell Crowe.
That's what Demar looks like with glasses.
Okay, Pete, read that one for us, Sarah.
Where's Pete at?
The bottom of 325. Isabella just read it, but nobody's paying attention.
You want me to read again?
Yeah.
The vegetation dies and is buried under an anaerobic condition, forming peat, partially decomposed organic matter.
So peat is organic matter that's been basically covered up and it's not able to break down. So that's the anaerobic, meaning oxygen's not able to get to it. Peat is something that could be fairly new. People cut this stuff up and they dry it out and they use it for fuel in various parts of the world. I've seen them do it in South America, down in I think Argentina or Chile, and then in England they used to do it, and all those like peat bogs that they have where there's not much wood available. But anyway, peat, the important thing about peat is it's the precursor to coal. Good. So over millions of years under heat and pressure, lignite forms. Did I pass around the coal yesterday?
No.
Okay, so I'll pass that around today. Now, basically, these are the three different types of coal, and this answer should answer number 10 and 11 too, as you're good looking through those. The three types of coal used for fuel: heat, pressure, and depth and burial contribute to development of coal. Here's some coal for you people at home. Merry Christmas. All right, so this is up from out in Brookwood. Somebody brought it to me. Fill it. This is what traditionally was burned for electricity.
You should put some coal in that stocking up there.
We should do it. Probably catch on fire. So now, over time and under a lot of pressure, it forms lignite. So lignite is our first type of coal. Lignite doesn't have a large amount of hydrocarbon like compression, and so it doesn't have a high carbon content, and it also has a lot of it has a lot of stuff in it that doesn't burn very well, and so it gives off a lot of ash and a lot of particles in the air that could be harmful. Okay, so it doesn't have a very high carbon content, which means it doesn't give off as much energy as the other types of coal. Okay, it's like the cheap coal. Yesterday, when you were mining your coal, how much dollars did you get per gram?
15.
15. So if you're getting 15 for bituminous coal, which is what yesterday was supposed to be, since that's the type of coal we have around here tomorrow, lignite, you'd be getting like $5 a gram. Okay, so subbituminous or bituminous coal is found at the surface or below the surface. This is formed under further compression and of lignite, and so basically you've got these hydrocarbons in that old plant material that is compressed further. There's a higher carbon content. There's less other stuff in there that's not good. I want to say trash, but it's just not. I can't even think of the word. Stuff that doesn't burn very well. And then the last one, anthracite. Anthracite's actually a different type of rock, even though it's still coal. Lignite and bituminous coal, those are types of sedimentary rock, so rock formed under pressure. Anthracite is formed under a lot of heat and pressure, as like coal would get like pushed farther down or go farther down in the earth. And so what type of rock is that's formed under heat and pressure? It's not sedimentary. It's
Integumentary.
No, it's I know what it is.
what?
Metamorphic.
Metamorphic.
Yes.
So anthracite is a type of metamorphic rock. Good. It's got a high amount of compression, so it's got a very high hydrocarbon content. It has less other stuff that's not useful, and so because of that, it's the best coal. It's the best coal for burning. When I say hydrocarbon content, it means it's got a lot of carbons and hydrogens, which means it contains more. The more hydrogen and carbon you got compressed into a smaller area, the more what it has.
Methane.
Yeah.
Oxygen.
More energy it contains. Good. So just like in your bodies, when you store hydrocarbons for energy, we call it
Food.
fat. Good. So in your belly or wherever you got your fat stored, fat is stored in the form of hydrocarbons, meaning lots of carbons with hydrogens attached. And so when it's burned, it basically breaks down and it gives off CO2. Okay? And so that CO2 is given off, released in the environment, and yeah, that's where, and the energy is given off in the process as well, and we're getting heat from it. So, any questions on those three types of coal and how they're formed? Super. Number 3, crude oil can be recovered from tar sands, which are a combination of blank and blank. So turn to page 330. Let's read about tar sands. Not to be confused with Tarzan. Yes. So, oil sands at the top of 330. Read that for Simona.
Oil sands are slow flowing,
Viscous.
viscous deposits of
Can y'all be quiet and listen? Bitumen.
mixed with sand, water, and clay. That word,
But it's bitumen, sorry.
bitumen, often called tar or pitch, is a degraded type of petroleum that forms when a petroleum deposit is not capped with non-porous rock.
Okay, so basically what we've got here is this bitumen, which is petroleum that didn't have anything kind of capped over it, and so a lot of the oil broke down and it's mixed in with sand and water and clay. And if you're talking about normal petroleum that flows out of the ground, like with like liquid, like black liquid that flows out of the ground, like we normally think of oil, crude oil or petroleum, what do you think the difference between it and these oil sands are in terms of getting energy from it?
It's not as good.
It's not as good because these oil sands are going to take what? They're going to take more time. They're going to take more effort. You extract them, and they've got all of this other stuff in them, so it's going to be harder to make them usable to get stuff out of them for the oil. So I'm going to refer to these oil sands as kind of the oil of last resort because it's a lot easier to just pump oil, liquid oil out of the ground than it is to try to get oil and the stuff we need from these oil sands. But I wanted you to be familiar with this. A lot of this is found like in Canada. They're talking about going in and digging for oil sands and shale, and I just think that that's probably our last resort when it comes to what oil do we need or what's left, what can we get after most of the oil is used up. All right, crude oil. Actually, let's turn back to 326. Petroleum. Petroleum or crude oil. Why do they call it crude, DeMar?
I have no idea.
Reagan. Unrefined. So that's a very good word you need to know. Unrefined means it has not been taken and the part's been getting out of it and things that we need extracted from it. So do we have a refinery here in town?
No.
Yes. It's called, Miss Higdon's husband works there.
For real?
It's called.
It's on the west side of town. What?
So she said it before. She has.
Hunt Oil.
Oh.
Good. So Hunt Oil, they take the oil, just like at any refinery, and so they heat it up. And if you look under crude oil there, crude oil can be further refined into a variety of compounds like tar, asphalt, which we use on our roads, gasoline, diesel fuel, kerosene, jet fuel. They are distinguished by the temperature at which they boil. So basically what happens is you take crude oil, you heat it up, and depending on when it kind of boils and evaporates off, then it's collected, and then it's sold off for whoever's buying it. So all of those things are coming off of crude oil. Okay? Yummy. Let's see what else here. Petroleum. If you go to the gas station in England, Peppa Pig, what might you call the gasoline that you get? Petrol, yes. So that's how they refer to it. That's just coming from the word petroleum, even though it's refined from there. You know, y'all watch it. So fossil fuels can be made into specific fuel types for specialized uses, and that's what I just talked about there on the asphalt, tar, gasoline, diesel fuel, kerosene. All of those in number 14 are specialized fuel types that we get from petroleum. Okay. Number 15, cogeneration. Co means
Together.
two. Good. So if you flip back to 324 here, cogeneration is the use of a fuel to generate electricity and produce heat. So you could use the electricity to power a building, and you could use the heat to heat a building. Good. I'm going to go in a different direction here than the fossil fuels we're talking about. I'll give you another example. In Europe, in a lot of places, they incinerate their trash. So they usually do this close to towns because that's where most of their trash is. And so they will incinerate their trash, and then a lot of times they will use the heat from that incinerator. They'll run it in pipes, they'll run it through buildings, and then they use that to heat those buildings. And then they can also use it for electricity generation. I'm sure in the summertime they still got lots of trash, and you don't want lots of heat being produced, so they use it for electricity then. So it's just a way of getting two things out of your energy production. Okay? Let's see. 16. We're going to stop after this one, so just bear with me here. Distribution of natural energy resources. The global distribution of natural energy sources such as ores, coal, crude oil, and gas is not uniform and depends upon what? Turn to 327. The distribution of those resources, Sarah, what does it depend upon? I'm going to say geology is the simple answer here. Geology meaning what rocks are found there, what was there. You could also say what was there previously. So, for example, coal, the coal that you passed around used to be what?
Rocks.
No,
It's technically a rock. What did it used to be? What made the coal?
Dirt.
lava.
Dirt.
Lava's not dirt. Andrea,
What?
what's coal made from?
Oil.
Wait.
Coal is made from oil?
I'm just guessing.
Lord have mercy. Turn back to 325. We just went over this for the love of God. What?
Peas.
Peat, yes. Plants. That plant material. It's broken down. So, decomposed organic matter, including mosses and other plants that broken down. Think like jungle. Think the swamps of when the dinosaurs were around. All these swampy pictures you see. So that plant material gets compressed and squished over time, and it forms coal. Okay. So the 4 places where you find coal, the 4 largest reserves are where?
United States, Russia, China, and India.
India, good. So that's important to know as well. So places where you find coal, like out toward Brookwood and in Jefferson County and in Walker County and Lower Winston County, all of those places used to have swampy, very productive habitats, and a long time ago they got covered up and squished, and that's where a lot of that coal formed. What about oil? Where does oil come from? I know, but what's it made from? Yes, it does come from underground. Very good. Antonice, start reading that paragraph on the bottom right of 326.
It starts with petroleum.
Yeah.
Petroleum is is formed from the remains of ocean dwelling
Phytoplankton?
phytoplankton that died 50 million to 150 million years ago.
Okay. So petroleum, the liquid stuff, if you're a fan of the Beverly Hillbillies, they called it Texas tea. That liquid black stuff that flows out of the ground, the crude oil, that is formed from basically little bitty ocean organisms a long time ago, and they were compressed under heat and pressure or under pressure, and formed what is now this gooey organic matter that we can burn called oil.
So basically fossil.
Yeah, it's like fossilized microscopic organisms from oceans millions of years ago. Yes, exactly. And this coal is the same thing. Coal is a fossilized plant material from a long time ago. Okay, it just has a very, very high. Both of those have very high hydrocarbon content, and that's good for burning. All right, so you guys need to get out your math problems now. I ask you guys to finish number 1 and just start number 2. So. See. I'm going to go over these with you guys because, look, I realize this is practice. If you're not practicing trying to work through these, then you're only doing yourself a disservice because when it comes test time, you're going to have a very difficult task trying to figure these out if you have not previously. So, the second part of number 1, we already did the first part the other day. How much energy do those kitchen lights use in a month? Well, so we want our answer to be in kilowatt hours. Okay, we know that's going to be on top. So our lights use 0.3 kilowatts, and they're running for 24 hours a day for 1 month, 30 days there. Days cancel out. All we're left with is kilowatt hours. And let's get that back. So when you multiply these 3 together, what do you get? How many of y'all actually did this? Simona, read it. What'd you get?
For the answer?
Yeah.
For the energy, I got 216.
216 kilowatts.
Yes.
What'd you get?
Yeah.
216. You multiply that times 0.08. What do you get?
1728.
So what you got, Anthony's? $17.28 usage. If you do not understand something, now's the time to ask questions. Yeah.
So I got the 216. So the 216 is the energy, and then the 17 is the
Cost.
Okay. The way that I did the energy was I did 15.4 kilowatt hours, like you got from the first part, over 1 times 1 over 7, 1 week over 7 days, times 30 days, 1 month.
That's fine. You just reduced it down to whatever you found in a. Just got it back to a day. Which seems like it may have taken you more time actually, but whatever works for you. Yeah. All right, and now if you find that for the year, all you're going to do is instead of 30 days, you're going to go to 365. Now some of y'all made the mistake of multiplying times 12. Here's why you can't just do what you had in that month times 12. What, tomorrow?
There's not always 30 days.
Yeah, if you take a 30-day month and multiply it times 12, how many days you got? 360. I'm glad y'all got good math skills. So that's not going to give you the same answer. So you got to multiply it times 365 days if you want the correct answer. Antonice, what'd you get for energy use for the year? 2,600 what? Oh, that sounds right. And then and you multiply that times 8 cents for every kilowatt hour, and what'd you get? $210 and what? Is that what you got, Simona?
No.
I don't know about that one.
Oh, wait, yes. Sorry, I'm looking at the wrong one.
Was it? Okay. I don't have my key in front of me. I'm just trying to get two people to verify.
I got 24.
24, is that right?
Like, no, 2024. No, 210, 24. Oh my god, I don't know what I'm saying. Hold on, let me make sure I do it. I like zoned out.
Yeah, it should be 24. Okay. You were pretty dang close, so. All right, now on number two, how much energy? So we were using an air conditioner now. How much energy does this air conditioner use, Damar?
1,500 watts.
All right, what do we need to do with that 1,500 watts, Damar?
What you need to do is, you need to, I don't know, that's Sarah.
I just told you the answer.
I wasn't listening
Convert
to you.
it.
Convert it to what?
Kilowatt.
All right, so we know we want kilowatts in the answer, so we gotta have
0.5 watts.
how much?
Too hard.
1.5 watts, leave me alone.
All right, so you're gonna multiply that times 24 hours. You gotta have kilowatt hours for every day, and for 31 days in July. And what's that gonna give you?
There's 31 days in July.
Yes. You didn't know that? Damn, 1.5 times.
All right, so go ahead and work through that one, and I want y'all to also work through the other two parts.